All right, so the agenda for today, yep. Just one member of the group is fine, as long as you have all of your names on there. And even if you don't, I have the people who are in your group, but it would be easier for me if you had all your names on it. Oops. Okay, so the agenda for today, we're going to start by finishing up some of the text stuff that we talked about last time, specifically the pattern matching stuff. I'm going to get through that, and then we're going to jump out of the slides, and we're going to review lab 1. Okay, so I'll just walk through all of that. After class today, I will actually post lab 1 to the GitHub repo, so when next time you poll, you should actually have my version of the lab. I would say it's a key, but it's not really a key, right? Because there's 18 million ways to solve these things, and my way might have been different from yours, but that doesn't mean that it's better than yours, right? It's just a different way of doing it. Then we'll get on to the sort of main topic of today, which is visual perception. We'll talk about aesthetic mappings and visual encodings of data. Then we'll talk a little bit about the data to ink ratio. And specifically, the main reason why I want to talk about that is because some people use it almost like as a religion, and I think that's wrong. So, and then at the end, we'll talk about some do's and don'ts, which are definitely all rules of thumb. And there's no, there are no hard and fast rules in data visualization, with the exception of maybe 1 or 2 things. But generally, there's almost nothing that you, like if you hear somebody say, do not ever use a pie chart, like I disagree with that. Okay, there's always room for different things. And so what we'll talk about are rules of thumb to help make your visuals better, but there's going to be situations where they don't apply. Okay. And then at the end, we'll jump into lab 2, which is posted now. It's been posted for a little while. Okay, so learning objectives, there's really only 2 today. The first one is to understand the basics of pattern matching for strings. I'll give you a resource to go and do some more learning on that, because we're not going to go super deep into it, and it's a really deep topic. Okay, it's and not that you will need to go that deep. For most of you, you'll probably, like me, you could get, I'd say 95% of your string manipulation stuff done with really, really basic pattern matching stuff. And then 5% of the stuff you're going to be like, well, how do I do this? And then you'll figure out some way to do it by like layering up a whole bunch of really simple manipulations on top of each other until you finally get to your output. Whereas if you start to learn some of this more advanced stuff, which, like, I've been doing this a long time. I've only really started using the more advanced pattern matching stuff maybe the last 2 or 3 years. So, so like, don't worry if you're feeling uncomfortable with it, because most people are uncomfortable with it. Okay, but if you get more comfortable with that, then, you know, rather than doing this big complicated do this and then I'm going to do this and then I do this and then I do this, you can just use one, what are called regular expressions, and it will just like parse through, find the pattern, transform it how you want it to, and you're done in 1 line of code. Okay, but there are drawbacks to that approach too, because if you're sharing your code with other people and they don't understand regular expressions, and they're going to see this string manipulation you're doing, and it's like, well, this makes no sense whatsoever, right? It just looks like gobbledygook. So there are pluses and minuses for sure. So just a quick reminder, the last part here is actually not really true. We're not really going to cover both. We covered both last time. I'm not really going to do that again this time. But just a reminder that there is the stringer package. Stringer package actually has some functions that are much easier, like string extract, right? That's a much better function than anything that I know of that exists in base. Okay. However, there's a bunch of functions also that are almost exact replicas of the base function. The only thing is you switch the arguments. Okay, so in that case, stringer is better, again, because it's more consistent, and you always know that it's going to be the string first and then the pattern, not the pattern first and then the string. Okay, and with base stuff, it's super inconsistent. With one function, it's going to be the string first and then the pattern. With a different function, it's going to be the pattern first and then the string. So that's really annoying. So stringer solves that problem. Okay, so there's reasons to use stringer. However, I typically don't. Part of the reason for I I think covering the base versions as well is because I would say most people, or I don't know about most, a lot of people don't use the stringer functions, or at least most stringer functions, okay? They'll use all the rest of the tidyverse basically, but not really stringer, and then you'll see them using grep and grepl and gsub and things like that, okay? So that's typically what I do too, and so that's what we're gonna mostly do here. Okay, I think this is where we got last time, but I didn't really talk about this slide, is that right? It's been like 2 weeks, so it's a little, if it's a little fuzzy, I don't blame you. But so we'll go through this a little bit, okay? So these are all special characters in a pattern matching sequence, okay? So a pattern, what you're gonna do is you're gonna have some function where you're gonna say, I wanna look for this pattern in this string, okay? So you're gonna have to feed it a string that is the pattern you're looking for. Like, you feed it blah, and it's gonna find all of the instances where blah is in some strings, right? But you can add these additional special characters to help you with the pattern matching. For example, if you add the little caret at the start, that's going to mean starts with, okay? So if you do caret A, then it's going to look for any word that starts with A, but it won't match anything that doesn't start with A. So if you had AB, it would match that, but if you had BA, it would not match that, okay? Whereas if you just had A, it would match both of those. Okay, you also have the $, which is another anchor, and that means ends with. Okay, one thing that's a little bit confusing about these is the caret goes before the next text. Okay, so it's like starts with this, and the $, goes after. So you'd say like bear $, right? So the $, goes at the end. It's saying here's the string, and then it ends there. That's what the string ends with. Okay. You also have all of these ones, the star, the question mark, and the plus, that are basically different versions of matches any character or the preceding character, rather, sorry. So it matches the preceding character 0 or more times, 0 or 1 time, and 1 or more times. Okay, so these are all very similar, but they're slightly different. All right. We also have these brackets, which are kind of neat. So this is an example where I'm saying match A n times, right? So if we're looking for words that have 2 consecutive A's in it, we could go A and then in curly braces 2, and that would only return strings where there's 2 consecutive A's. All right. You can also say n comma, and that's going to say 2 or more, or 3 or more, whatever you put in for n. And then finally, you can use n comma m. So you could say 2 comma 4, and it would look for instances of 2 A's, 3 A's, or 4 A's, but nothing else. Not 1 A and not 5 A's. Okay, in a row. The dot is just a wild card. It means match any character, and that ends up being very useful. I use it all the time. The pipe, this kind of pipe, just a vertical bar, is or. And that's another really simple one that's very powerful, right? You can say black or brown, right? Or whatever, green or red, okay? And then you also have the square brackets, and those can be used for actually quite a few different things. One of them is that there's this whole sequence of things like this, like digit, where you can search for digits within a string. There's also ones like alpha and whatever. There's all sorts of different things like that that you can put in there like that, and it will look for them. And then there's these shortcut versions of them too. So this is digit, and if you did / lowercase d, that would be the exact same thing as this. Okay, and we'll see an example of that later. But the brackets are also used for specifying sort of ranges of things. So if I did brackets and I just said A-F, it would look for anything that has the letters A through F in it. Okay, you could also do an uppercase A and a lowercase a, and you could put a caret on the outside of that, and then it would search for anything that starts with either an uppercase A or a lowercase a, so you don't have to worry about case in that instance. The parentheses are used for back referencing, look aheads, and groups. That is quite complicated. I'll show you one example of that near the end. That the back referencing in particular, though, I use all the time ever since I learned it, and it is super powerful. So I'll show you an example of it. And then the slash, that's how you escape any of these characters. So very regularly, for example, you want to find something that ends with a question mark, right? Well, you can't just put question mark $, because the question mark is already itself a special character, says matches the preceding thing 0 or 1 time. So instead, we need to escape the question mark to say, actually look for the question mark. Don't use the question mark special operators. Okay? Questions on any of that? Okay, I know that's fast, and we'll come back to it, and I'll give you more resources. Okay? These are the two primary resources. The first one is just the RStudio cheat sheet. There's this is linked there, so that would download a PDF for you. The second is this regular expression vignette. This was written by Hadley. I think it's written by Hadley. This is super good. I think it's quite in depth. They also link to the strings chapter, but they talk about all sorts of different ways that you can match characters. Here's the anchoring stuff I was talking about with like starts with. They're using stringer all the time, but here's string extract, right? So caret A, so it's going to get apple, but not banana or pear, right? And actually, in this case, it's just pulling the A out of it because it's string extract. Okay. And there's a whole bunch more here. It goes into a lot more detail than I'm able to go through in these just few slides. So I would really recommend at least just skimming that and spend like 10 minutes with it at least, just so that you get an idea of some of the other things that you can do with string matching. Okay. So we're going to do a few quick examples. Please follow along. Go ahead. I'll give you a minute and a half-ish to get R going. Run library edld 652, and then D get data this one. Okay. And then after you get that in, I've got a little challenge for you that we're going to do for about 5 minutes. Okay. Hopefully that was enough time. If not, you'll have more time here in just a second. So now here's my little challenge for you, okay? For the next 5 minutes, I'd like you to just work where you're at. You can work with the person who's at your table if you want. But basically, I'd like you to try to do 3 things with this data set, okay? First is I would like you to create a new variable in your data set that identifies whether the LEA, the Local Education Association, or agency rather, is associated with a city or a county, okay? So if we look back here, you can't see it. So that's not very helpful. But if you look at that variable for the LEA, you'll see that they say that something city or they say something county, okay? So just create a new variable that identifies whether it's a city or a county, okay? Then I would like you to drop city or county from the LEA name, okay? So it should only say blah, not blah city, okay? And then finally, this one's totally artificial, but I wanted something to have you practice escaping. In the URL, replace all the actual dots with dash dash dot in caps dash dash. Okay, so you'll need to use either base G sub or stringer string replace all to do this. Okay, so 5 minutes. Go ahead. Okay. So again, if you didn't get all the way through, don't worry about it at all. We're going to go through it now. And if you did get through it all, great. In fact, real quick, everyone who is here, and I'll change the window here. So, oops, that's not what I meant. That way. There we go. Okay. So those of you on Zoom, just give me like a thumbs up or a thumbs down if you felt like how you felt. And then in class, can you give me like a 5 if you felt awesome and like a 1 if you felt terrible? Okay. So most are between 1 and 3. So that's okay. We probably need to just work on this some more, and you need to practice more. And so we'll try to embed some of that throughout. Okay. But here's how I did it. And again, there are multiple ways that we can do this, right? But this is the first 2 here are totally reasonable things that you might actually do with your data set, right? The third one, as I said, is totally artificial. But the first two are very reasonable things that you might want to do with your data set. So how do we do that? Well, this is how I did it. First, so I'm skipping your ideas because you already did it. It's fine. So the first is I used grepl, right? Which grepl is going to say search L for logical, right? So it's going to return a true or a false. And so I said search for county $. So it's going to end with county. And then notice I said to lower LEA name. Okay, you don't actually, in this specific case, you could actually just have a capital C here, and you wouldn't actually have to even have the $sign there, but it makes it a little more safe, right? And by putting it in lowercase and then saying to lower here, then I'm very confident that I'm getting all of them, because whether it says county in all uppercase, if it says county with in like title case or in lowercase, it's going to get them all because it's transforming LEA name so they're all lowercase before it does the searching. Okay, so that's one way. Another option is to do something like this, grepl again, but this is again just to a different way to control for the case. In this case, I'm just saying county with both upper and lowercase c, and then $sign in LEA name. Okay, so this is saying look for either uppercase or lowercase c in county, and then look at that through LEA. Okay, any questions on that? So both of these are going to create a new column in my data set called county, which is just going to be a logical variable that's true or false. Okay, and so we can look at this very quickly here. I'm just selecting the LEA name and this county variable I just created, and then I'm saying, okay, print 15 of them. And so we get Albertaville City, so county is false, and then we get Marshall County, and so county is true, right? And you can kind of check through here. There's only 2 counties, but they're both true. And if we really wanted to check, we could, look at more rows or whatever. Okay. All right. Now, what about removing city/county from the LEA name? So again, I said that I would probably use base G sub, but you could use string or string replace all. Okay. There's many different ways to do this. But what I would do is just say, okay, well, given that these things look like this, right? Some city name and then a space and then either city or county. I'm just going to look for the space, and I'm going to replace the space and everything after the space with nothing. Okay, so that looks like this. And again, there are many ways to do this, but this is the more like kind of regular expression way to do it. Okay, so I'm saying look for a space, then any character that comes after that, that's what this dot is, any number of times, that's what the plus is for. Okay, and it's going to replace that with nothing. Okay, so it's looking for the space and then any characters after the space, any number of times, and it's replacing that with nothing. Okay, so then our new name one just looks like that. The other thing we could do here, if we wanted to maybe make it a little more explicit, you can also use this //s, which means look for a space. Okay, so it's the same thing as this, but it's maybe a little more explicit, but it's actually less clear if you don't really know regular expressions and what you're looking for. Okay, so that's another option. Another way we could do this same thing, and again, there are plenty of ways, these are not the only ways, but another way we could do this is we could say, look for the space and then city $, meaning it ends with city, or, right, that's what that pipe there is for, or a space and then county $, and in either instance, replace it with nothing. Okay, and we get the same thing. Okay.
Hi, Daniel.
Yep.
Quick question. So the previous slides, you add +sign. Do we always have to tell that to like it do all all the list, or just without it's fine?
You have to have the plus sign in this case because you're saying find the space, right? And then you're saying any character, which would be like C or I or T, but you're saying any number of times. So it could be city or it could be county, right? These are different lengths. This is 1, 2, 3, 4 versus this one is 1, 2, 3, 4, 5, 6.
Oh,
That
okay,
makes
okay.
sense?
Yep, thanks.
Yeah, so this plus is saying this thing any number of times. Whatever the character is, any number of times.
Got it, thanks.
Yep, good clarification. Any other questions? I think a lot of this pattern matching stuff is one of those things where it's like, after you see it, it's very clear, right? But like coming up with it on your own is a lot more difficult. So if you didn't come up with any of this stuff on your own, but now you're seeing it and it's like, oh, duh, that's easy. Like that's pretty normal, okay? All right, and then the final step, we want to replace the dots with dash, dash, dot, whatever, okay? So again, this is fairly artificial, but we're trying to practice. So that's what we're doing, okay? So dot is a special character, so we have to escape it, right? And so what we do then is we put a slash in front of it. However, the slash itself is a special character, so we have to escape it. So functionally, we use double slash to escape anything, okay? So this is what the file URL looks like, right? And if I'm going to make those replacements, it would look like this, okay? So I'm saying mutate file URL gsub / dot. So I'm saying actually look for the dot. Don't look for any character, right? Actually look for the dot and then replace it with this, okay, in the file URL. And you can see it worked, okay? Questions there? The only reason I have this as.data.frame down here is to get it to print better for my slides. So that's not something you would actually do. Any questions? Okay, one other thing I meant to put in here, but I didn't. Gsub also has, yep, go ahead.
Oh, never mind.
Okay. Oh, yes, because it's, here, let's go back here. There's a dot there and a dot there. Right. So the other thing with gsub is it has a, now I forget what it is. Let me look real quick. We go like this, our studio. And switch my share. Stop sharing. Share. Yes. So if we go here and I just say gsub, you will see, so we have this ignore.case, which is kind of nice. So you can ignore whether it's uppercase or lowercase in your searching. And then there's this fixed argument. Okay, there's other things in here too that I don't think are as important, but the ignore.case is nice, although I typically just make those transformations on my own, as I showed you before. But this fixed one is also nice because that's another way to avoid escaping. Okay, so fixed will not use a regular expression. So you can just put a dot, say search for the dot and replace it with whatever you want and say fixed equals true. And then it will go ahead and search, it will replace all the dots with whatever you told it to without having to escape the dot. Okay? All right. Oops, that's not what I want. Where'd it go? Oh, shoot. Okay. So.
Hi, can I interrupt the
Yeah.
just a second?
Sure.
Hi, by the way, I'm David Leibowitz. I'm a professor in the Education Methodology Policy and Leadership Department. I teach an advanced methods course. I just had the first set of students turn in their programming assignments for this methods course. A subset of whom had taken the data science sequence. All of them were amazing programmers, beautifully written functions. It's a beautifully taught course, a beautifully taught sequence, and you guys are going to learn a ton of skills from this course. And I just was like blown away by the quality of the work that the students did, and it's a testament to Daniel. So
Thank you.
I've left you on.
Thanks,
Sorry,
David. No, thank you. Yeah, that was very nice of him. Okay, where were we? Now I'm all flustered. Okay, so a few more examples. So here we have just some basic strings, ABC, A23, DEF, whatever. So let's say we wanted to remove the digits, okay? I mentioned this before, you can do this //D, right? That's gonna look for a digit. So in this case, I'm saying G sub //D, nothing. So I'm saying look for the digit and replace it with nothing. So you can see that just removes the 2, 3, and the 6 from those strings, right? Alternatively,
Daniel, we are still looking at your R.
Shoot.
No worries.
Sorry, there.
Yeah,
Now you
yeah.
can see, right?
Yes,
Okay.
yeah, thanks.
Sorry about that. Okay. So we can use the //D to look for a digit. The other thing that you can do is you can, instead of using a lowercase d, you can use an uppercase D, and then it will look for any non-digit. Okay. So in this case, I'm using the uppercase D and I'm saying replace it with nothing. That's going to replace everything that is not a digit with nothing. Okay, so it's going to return only the digits. Okay, and then this is like another example of starts with upper or lowercase a. Okay, so there's a ton of this kind of stuff. There's a whole bunch more. As I mentioned, back referencing is kind of an advanced topic. I'll just show you one quick example of this. Okay, and this is this is just a quick example of this. There's lots of cases I use this, but this is not something that you should feel like you should be using anytime soon here. Okay. All right, so we start out with these cities. We've got Eugene, Oregon, and Denver, Colorado. Okay, those are our two cities. And what I'm going to do is I'm going to use G sub with back referencing to create a sentence that uses those cities. Okay, so I'm saying starts with, and then I'm using these parentheses to say anything, whatever it is, right? Anything, any number of times, and then it ends, and then there's a comma. Okay, so again, it starts, and then there's any character, any number of times until the comma. Okay, then there's a space, and then there's some other digits, any number of times, or not digits, some other characters, any number of times until we reach the end. Okay, so what I can do now is I can use back referencing where this one and where I have two things that I can back reference, right? Two things that are in parentheses, the first one and the second one. I reference those with //1 and //2. So in my replacement down here, I say the state of //2, that's going to be this thing. It includes the city of //1, that's going to be this thing. Okay, and you can see our output is the state of Oregon includes the city of Eugene, the state of Colorado includes the city of Denver, etc. Okay, and you could do that for however many. There's all sorts of other reasons why back referencing is, I think, useful. But that's just a quick example. Okay, and again, that's a more advanced topic, but it's just kind of a neat thing. Okay, so that's it for the pattern matching stuff. The next thing I was going to do is review lab 1, but before we do, are there any questions on any of that? I think this is it. Yeah, lab 1. Okay, so this is how I write the labs always, right? They're just an R markdown, and then I wait until it's you've all turned it in, and then I just post this, which is just what I used to create it in the first place. So we're not going to really talk about the Git stuff. I was very happy with all of your Git repos, seeing the branches and the pull requests and everything. I think the more you do that, the better, the more comfortable you'll get with it, and it'll become more second nature, and that'll be good. But were there any hangups people had with the branching and the merging and things like that? Okay. All right, so we're going to start out here. I'm going to import the data. I'm just using Rio import because it's an RDS file, but you could also use read uppercase RDS or read _RDS from the readr package. Either of those would work as well. And in fact, that's typically how I do it, but I know you mostly used Rio in the last class, so that's why I have that here. So we have this initial exploration where we're talking about histograms and density plots, and we were supposed to look at different number of bins for the histogram and the bandwidth for density plots. right? So I'm going to just load the tidyverse. It's going to load all these packages, and then I can play with this. So I have D here, right? And I am going to look at this display text width, right? Right here, which is basically the only like numeric column in here, which is why we did that. So I'm going to start out by calling geom histogram, and I'm going to say bins equals 30, and it looks like that. Okay. I could do bins equals 50. Looks a little more spiky. Bins equals 40. Looks like that. Bins equals 30 is the default, remember. And then bins equals 20. So you could kind of make an argument for anywhere in this range, I think, anywhere in the, well, really anywhere in the 20 to 50 range. There's different reasons I think that you might like them. But to me, this one with 40, I felt like was best because it shows the overall distribution. It also shows this steep spike right here before a real sharp drop off. But then you can kind of see this long tail and a little spike there near the end. So I thought that was good. Part of this is probably because Twitter changed how many characters they allowed, right? So that's probably partly what's going on there. So I thought 40 looked pretty good, but it's, you know, somewhat opinion based. Okay, then with the density plot, I had it fill with gray 20 to start. And I just left it to start like where I'm starting out. I just let it do its default algorithm to figure out the bandwidth. And that looked like this. And I think that looks pretty darn good. That actually looks similar to what we saw with the histogram with the 40 bins that I thought was preferable, right? So then we're going to try again. I'll put bin width to, or bandwidth to 0.2. You can see that's super spiky, right? So that's probably not very good. So I'll go up a lot, up to 1.5. That looks pretty good, right? Go to 3. That's looking even a little smoother. And 5, that's probably a little too smooth, right? So you can kind of circle through these. They all look relatively similar. I actually think in this case, the default bandwidth looks really good though. So that's probably what I would go forward with. But I still think it's, and the other thing that's kind of reassuring here is the overall message is not really changing across these bandwidths, right? So that's telling you, in this case, the bandwidth probably isn't the most important thing. Okay. Now we're going to look for plot. Okay. So we're looking for plot in text. So again, if I just look at D here, you can see we have this column. Let me actually do it like this. You can see we have this column that is text, right? And the text is the actual post that they made, that the people made, right? And so what we're going to do is we're going to search through here and we're going to look for plot. Okay, I had a couple people ask me if it should be the word plot or if it should just be plot as in like ggplot, right? And I was not clear on this, what you should do. So either approach I think is fine. I was just looking for plot, not the word plot necessarily. And so the way I did this is I looked for plot and notice I said to lower again. So this case sensitivity thing is going to be a recurring thing with string manipulations. You've either got to ignore the case or you've got to do some sort of transformation so that you're looking within a consistent case. Okay, so I'm looking for plot in to lower of text. So I'm transforming all the text to be lowercase and I'm doing grepl. So notice grepl is just going to return a huge logical vector, right? A bunch of trues and falses. And the nice things about logical vectors is they coerce to ones and zeros when you make them numeric. Okay, so if you coerce a logical vector to numeric, the trues will become ones and the falses will become zeros. And so what you can do then is just sum that, and that will give you the number of times that plot was in there. So we can look at this and we see 29,353 times. Okay, so then all I have to do at that point is just divide that by the number of rows in the data set, and I get my proportion. And if we wanted it to be an actual percent, we could do that too, right? There's your percent. And we could make it a little prettier. Let's zero that with percent. And there we go. Except we probably want to round this wait, round this to 2 digits. We'll go 4 digits. There we go. 6.83%. Okay. So that's how I did that. And I know because I've already looked through all of yours, right? I've given you feedback. If you haven't seen your feedback, I've put all your feedback in as I filed them as issues in your GitHub repo. So I was happy with how everybody did this. I know some people broke it into words first and then searched through that column. That's fine too. This was I thought the easiest way to do it. Okay, the next thing we're going to do is create the plot rough draft. Okay, so what I'm doing is I have D, right, my full thing, and I'm just going to, you don't actually have to do this, but I was just doing it to make it a little bit smaller. I'm just selecting the user ID and the text out of there. So here's the user ID, and notice the text doesn't even show up because it's so wide, right, on the way that I have it now. So then I'm going to unnest tokens. I'm going to create a new column called word, and those words are going to come from the existing text column. Okay, so this will take a second to run, well, a few seconds to run. And I think everybody looked like they did this correct, which I was happy with. And so now we see words looks like this. Okay, now to create the rough draft of the plot, I'm going to first use this anti-join with the stop words, right? That's going to get rid of and, of, the, etc. And then I'm going to also get rid of these. And the only reason I know to get rid of these is because I had previously created a plot that included these, right? And I don't want those things in there. So like this is Twitter's link shortener thing, HTTPS, HTTP, RT for retweet, right? And rstats. Obviously, they're all going to have rstats in it. So that's not very meaningful. So I just say where word is in these things. Okay, so this part, notice I am not including the exclamation point in that highlight there, because what this is saying is it's saying, is word, the word, in any of these, right? And it'll return true or false. But what I actually want is the opposite of that. I want the words that are not included in that. And so right all the way up here, I include the exclamation point, which transforms all those trues to falses and all the falses to trues. Okay. Then we're going to just count word and sort equals true. Oops, can't find words. So we'll go there. Okay. And then from there, we're just going to transform word by making it a factor. Okay, so here they all are. We're going to make word a factor, and it's going to be a factor that is ordered according to n. So that's what this part is. And then we're going to slice 1 through 15. So we're just taking the top 15 words. Okay, so I do all of that. And now the actual plot is pretty simple. I'm going to put the n on the x-axis, the number of times that word was there. And I'm going to put the y on, or the word on the y-axis. Okay. And then I'm using geom call. Anybody remember why I use geom call instead of geom bar? Yes, so geom call will go according to the y-axis that you have, whereas geom bar, unless you say stat equals identity, if you call geom bar with stat equals identity, that's the exact same thing as geom call, right? So it's just a more abbreviated way. Geom bar generally is going to try to do some summary operation like compute the mean or count the total number or whatever. Okay. There's our plot. I don't know what that is. Yeah, I was like, I don't think that's me. Yeah, no worries. Okay, so here's the rough draft of our plot, right? And that's cool. And now we're going to stylize it. We didn't really talk about stylizing plots very much, but I was really happy with how you all were able to do this. So you must have either known a lot coming into this class, or you just did a lot of research. But this is what the final plot was going to look like, and it looks all squished in there because it is, right? But that's basically what we want it to look like. And so there's quite a few different things here that I ended up doing to make it do this. So I'll just kind of talk through them And again, if you didn't get all the way through this, that's totally fine. I wasn't that concerned about it. I just wanted you to try styling a plot a little bit, okay? So this first part is the same. When we do geom call, we're now just going to do alpha equals 0.9. So we're adding transparency to the bars. I'm making the color cornflower blue, right? That's the outline of the bar. And then I'm going to fill it with cornflower blue too. But when I'm filling it, it's transparent. So the actual outline is going to be a little bit darker than the inside. This part, I do basically every time I create a bar chart. And what this is doing is we're going to say along the x-axis, we're going to expand equals 0, 0. This is actually reducing the expansion. So if you look back here, there's a fair amount of space here between the word and the bar, and it drives me crazy, right? Especially depending on the aspect ratio, it can be really bad, right? So if it's like this, see how much space there is there? And what that expansion is doing is it's scooting them a lot closer. You can't really tell here because it's been so squished in there, but it puts the labels a lot closer to the bars, okay? And then we're changing the labels. I think all of that is pretty self-explanatory. And then we're changing the theme to theme minimal. And then through this theme part, this is another thing where it's like, I was not fluent in the theme forever, like again, until like maybe 3 years ago. And like, I've been doing this forever. So, so this is not something that you should expect any sort of fluency with for a good long while, okay? Unless you're just modifying plots all the time. But basically, I'm changing, yeah, you can run through each of those on your own. The one that I will mention is this one, plot.title.position equals plot. That's what takes the plot from, so here, let me show you real quick. I'm going to take off this base size equals 20, put it down to like 5 even, just to make it really a lot smaller. So if I take that off and I create this again, hang on. Okay, so you can see these are a lot closer now, right? But notice the title is right here. It's right above the bars, right? If I add that thing back in there, so I'll go there, right? If I add that back in, then when I run this, watch what happens to the title. See that? Now it gets shifted to the left justification of the plot instead of being right above the bars. That is a stylistic choice that you may like, you may not like. I tend to prefer it because it's more justified, I think, with the flow of the text within the paper. But some people think it looks awkward. I don't know. I think it looks awkward the way it is the other way. So whatever you prefer is fine. Okay. So that is the lab. Again, I will post this up right after class. Any questions on any of that before we move on? Great. Okay, so we're pretty far into class here and finally getting to the topic of the day. We have probably another hour-ish, and then I'm going to release you for the lab. Okay, so even if we don't get through all the slides, you'll always have at least half an hour for the actual lab. Okay. All right, I always like to have this disclaimer on this one because I am not a psychologist, and I very regularly have a lot of psychologists in the room when I'm giving this talk. So I don't really know why we perceive things the way that we do. That's not something I study, right? But I mainly care that we do perceive things certain ways and that your visualization should account for them, okay? The other thing that is sort of a running theme throughout all of this stuff, because this is really like our first major lecture on data visualization, right? Is accessibility, right? Making your plots as accessible as possible. And I don't ever really have a specific like lecture on accessibility, but that's sort of embedded throughout a lot of this. Okay, so here we go. I need to get rid of this thing. Maybe I can put it there. That's not helpful. Okay, whatever. That's fine. Okay, so visual cues. When you are creating a visual, right, there are generally only a limited number of ways that you can do that, right? So you can show data by position. That's going to be pretty common. So you can think of like a bar chart or something like that, where you have like numbers that are scaled 1 to 10, and then that bar is going to go relative to the numbers 1 to 10, right? You also have, well, that's also more like length. Okay, so position is more like position in space, like you could think of a point in a scatter plot. And then angle, how wide, parallel to something else or not. And then direction, right? So like at what slope? So again, thinking of like a regression line and the slope of that regression line, time series plots, that sort of stuff. You also have, for more discrete data, right? You have shape, which is going to be categorical pretty much always. So you could have circles versus squares versus triangles, whatever. Area, how big in 2 dimensions. Usually, again, like I said, if you have like squares, you're going to want to scale that by 2 dimensions. If you pretty much don't ever want to scale a square by 1 single dimension, that's going to be problematic. But you also could do things like circles that you're scaling by a single dimension, and you'll have some distortion there, but it's generally going to work better, at least. Volume, again, same sort of thing. And then shade and color. So shade is almost always going to be numeric, but it can be categorical. If it is categorical, it's almost always like a numeric variable that has been binned into categories, right? And then color can absolutely be either, right? We use it for categorical all the time. So we're saying like red means this, blue means this, green means this. But we also use it for continuous data all the time too, where we have like shades of blue. So like white might mean very little, and like a dark blue means a lot, or maybe it's the opposite of that, right? So different ways of encoding data. We have the X and the Y axis. We talked about shapes and colors already, but we also have things like lines, right? This is different line widths or different line types could be associated with either amounts for the line width or types, which could be either line type or line width. There are other things to consider within your visual as well, including text, which we've talked about just a tiny bit, but like how is the text displayed? What's the font, the face, the location, all of that stuff. This is really, this part of data visualization, I would say most like practitioners of data viz don't really think about it very much. And by practitioners, I mean like most, scientific producers, like people in academia. People who do this for a living absolutely think long and hard about text choices, text placement, all of that stuff. But it's a much more important consideration than I think we give it credit a lot of the time. Okay. The face also has to do with accessibility. There's lots of fonts that are inaccessible for different types of people, different types of disabilities like dyslexia and things, and there's different font faces that can be more accessible for those people than others. Okay, people that have those types of disabilities. Transparency is another thing that we use a lot, like especially if you have overlapping pieces, then transparency can really help there. And there's going to be some times where it really requires that you use transparency. Okay, like for example, if you have overlapping density plots, if you're not using any transparency there, then you're just not going to be able to see the plots that are underneath the other ones. But there's also times when we can use transparency for things that we might not typically think of, like for example, scatter plots, right? Transparency can be used with a lot of really well with scatter plots when you have a lot of data, because you can make the points themselves have just a small amount of transparency or a lot of transparency, depending on how much data you have. And then what you can get is you can get a visual of the data density in addition to the overall sort of trend. So it's not just that the trend is going like this, but you also see that almost all of the data is right down here at the bottom left corner of the plot, right? And so you have this overall relation, but really most of the data is right here. And you can do that through effective use of transparency. types of data, that's pretty obvious. Okay, so what I'd like you to do now for the next minute or so is look at this data. Some of you, if you've seen some of my other talks, you might have already seen this. So, oh well. But we're going to look at this data, and then I want you to just imagine that the date here is all just one variable. So you're going to concatenate those columns into a single like date column, right? But then you have the location, the station ID, and the temperature. So I would like you to talk with your neighbor and think about how you would visualize these data. Okay, so I'll leave it pretty open. How would you visualize these data? Okay, I'll give you about 1 minute. Ready? Go. So like what's on the x-axis, what's on the y-axis? You using points, lines.
Or wait, for location would be like x and y axis. Oh, it's saying all together. Okay, I thought it was just saying, but okay. Oh, because it's just a. Yeah, so it's basically like a unique identifier.
Okay. So who wants to share what's one way that you would think of visualizing these data? And there are no right or wrong answers here, right? There's lots of different ways that we could do it. What's one way? Yep.
We came up with a spaghetti plot with time on the X, temperature on the Y, and then separate either colors or shapes with connected lines. Like
Perfect. So, oops, I always mess this up. Like this, right?
Yeah, or I was looking at point estimates.
Yes. Yeah. So you could overlay the points on top of there as well. Yep. So that that would be my initial reaction to is something like this, where you have time along the x-axis and then temperature along the y-axis, and then you have different lines representing each location. Okay. Notice I'm ignoring the station ID here because that is actually kind of irrelevant. What we're really concerned about is the temperature. Okay. And if we wanted, we could also overlay the actual points on there so that we see how many measurement occasions we have throughout there as well. Okay. So in this case, actually, let me go back here a little bit. When we're looking at this data, we also have to think about our scales, right? So a scale defines a mapping between the data and the thing on your plot, right? And the thing that is interesting about this is that it's not just like, okay, well, I want this to be like numeric and it's going to be on the x-axis. Like, yeah, that's cool, but then it needs to actually represent your data well. So you need to have that x-axis be an equal interval scale then so that you can visualize it on the same continuum, right? And this gets more complicated when we talk about colors, which we have an entire lecture on colors. So we'll talk about that more then. So if we're thinking about scales and the previous one, we're thinking about what data values correspond to this specific aesthetic values. So we have position, shape, and color. And then this is what we're looking at here. So we've got two continuous scales, right? We've got month, time, basically, on the x-axis, and we've got temperature, right? Two continuous scales and one discrete scale, right? Which is the location. So the two continuous scales in this case are mapped to like location, but then we've got the discrete scale, which is mapped to color. Okay. If we wanted to actually create this plot, I have this data in a temps long thing, but that doesn't really matter. It's very straightforward, right? We would put the date on the x-axis, the temperature on the y-axis, and then we're going to say geom line. But then within that geom line, this is the only part that's maybe not so straightforward. We'd say AES, so aesthetic, right? We're pulling in an aesthetic mapping. The color is going to be mapped to location. Okay, and that creates different lines for each location. Okay, and because I said color, we're also getting different colors for each location. If I said group equals location, they would all be the same color, but we'd still get separate lines. Okay. All right, what if we wanted to change the colors of the previous plot? So this is, this coral color, green and sort of teal and purple. What if we wanted them to be some other colors, right? And specifically these colors, I think I mentioned this before, don't tend to work very well for color blindness simulations. So what if we wanted to change the color? Well, in this case, right, we have our aesthetic mapping for color. So color is being mapped to, or rather, our data is being mapped to a color scale. So what we have to do is change the color scale. All right, so we have some existing color scale that ggplot uses, and we want to change the color scale that's being used. Okay, and the reason we have to change the color scale is because the data are mapped to color. Okay, versus if we just had said all of these colors are going to be blue, right? Or all of these lines are going to be blue. We wouldn't actually have to change the color scale. We're just changing it more globally. All right. So to change the color scale, we do something like this. There's a whole bunch of different ways that we can do this. There's a whole bunch of almost uncountable number of palettes that you can use. Okay. You can also do scale color manual, right? But it's always going to take this form where it will be scale color something, right? Scale color brewer is a very common one. And we're saying palette equals dark 2. So we're saying change the color scale palette to the brewer from the brewer family, the dark 2 palette. Okay. And then that ends up looking like this. So that's the dark 2 palette from the R color brewer library. Okay. So again, the reason we're doing this is because we have to actually change the color scale because the data are being mapped to a color scale, and we want to use a color scale other than the default one. Okay, which is different than if we want to say make all of these bars blue and make their outline red or whatever. Does that make sense? Okay, we're going to talk about colors a lot more later. So yeah, I've kind of been trying to say this the whole time. You only use scale color, whatever, if you're mapping data to color. Otherwise, you don't. Okay, that scale color, whatever, is only used when you're mapping data to color. The other thing that's important is that you keep straight your color scale and your fill scale, right? So you use scale color, whatever, and scale fill, whatever, to do those. And you can make them separate things. Okay, what about an alternative representation? So we have this version where we have a continuous x-axis, continuous y-axis, we have 2 continuous scales, and then we're mapping color to a discrete scale. Can you think of a different way of representing the same thing? So we have the same data, basically. Can you think of a different way of representing it? Heat map. Good. Yes. Heat map. Next slide. Okay, and so this is now representing time with a discrete scale, right? And we have location as a discrete scale too, but it's now using a position scale instead of color scale. And then we're using color as a continuous scale. Okay, so we have 2 discrete scales and 1 continuous scale. That 1 continuous scale is a color scale this time, whereas our color was the only discrete scale before. Okay, so the basic way that we create this is we take our temps long thing. We're going to group by location and month. So 2 discrete things, basically. And then we're going to summarize, compute the mean temperature for each of the location month combinations. And then we're going to put month on the x-axis, location on the y-axis, and then we're going to use geom tile. Okay, and we're going to say fill is temp. And notice I have AES in there because temp is a column in my data set, right? And then I'm saying color equals white, which is again just the outline of the tiles. Okay, and then the last thing I do is I say chord fixed, which makes these each perfect squares instead of like rectangles, which I think just generally helps. Questions on that? Okay, and then we could also change the palette on this one too if we wanted to. So from, in this case, I'm using this Sicko or whatever library, and then scale fill Sicko with the Tokyo palette in this case. Okay. Again, there's all sorts of different color palettes out there. Okay, so both represent 3 scales, 2 position scales, X and Y axis, and then 1 color scale, but in different ways, right? More scales are, of course, possible. So here's an example where we have, you know, position scales for the X and Y axis that are both continuous. And then we have this continuous one for weight where we have the circles that are scaling up. So bigger circles are more weight. And then power, so the circles themselves are colored according to their power. And then this number of cylinders is also going to be the different shapes. Okay, so in this case, there's a lot of structure to the data, and this kind of works, but it's a lot of information going on, like a lot of stuff that's happening in this one single plot, right? Generally, I would say you should avoid doing this kind of thing. This is just a lot of stuff. And this is a better example of it, where you can see when there's like tons of structure in the data here, you can almost draw a horizontal line separating the circles from the triangles. And then you can very clearly draw vertical lines separating the colors, right? When there's a ton of structure